study the physical quantity called electric flux. To understand electric flux, we use the simple diagrams and some terms. Here is a first term is electric field intensity. The electric field intensity is more if electric field lines are closer to each other, and electric field intensity is weak if electric field lines are far to each other. In these two diagrams, we see clearly these field lines are closer to each other. That means electric field intensity is high, and this diagram we see electric field lines are far to each other, so strength of electric field is low. Electric flux, to understand electric flux, we all clear first that electric flux is number of electric field lines crossing the given surface normally. The red surface is bounded some area. If some electric field lines crossing the given area, then the number of electric field lines is called electric flux. The three basic factors which affects electric flux, three basic factors which affects the electric flux. What is electric flux? Electric flux is number of electric field lines crossing the given surface area normally. Okay, let us start point by point. The point number 1, electric flux is proportional to electric field intensity. As we discussed, electric field intensity is less if field lines are far to each other. Electric field intensity is strong if field lines are nearer to each other. So, phi is proportional to E. Here is only two field lines crossing the given surface. The same surface area we see here, in which 1, 2, 3, 4, 5 field lines crossing the given area. That means number of electric field lines more will be the electric flux. Number of field lines low be the electric flux. E here low, E here high. That means flux is proportional to E. E high, field lines far, flux low. E high, field lines closer, flux high. So phi is proportional to E, concept number 1. The second factor is phi is proportional to area of given surface. If area is high, more will be the number of field lines which crossing the area. If area is low, less will be the number of field lines which crossing the area. Here is high electric flux, here is low electric flux. This is very simple concept that flux is always proportional to area, more flux, less area, less flux. The last and most important concept number 3, based on angle between area vector and direction of electric field. The direction of electric field is from left to right in the whole region. The three parts of a plane. First part, the area vector of the given area is in right side. Electric field intensity also is in right side. So the angle between area vector and E vector will be 0 degree, and we all know cos 0 degree is +1, which is maximum value of cos. If angle is least, then the value of cos is more. Second diagram, we see that if the surface area is tilt, then the area vector also tilt. In this case, angle between area vector and electric field intensity is acute angle. Acute angle means the angle is greater than 0 and the angle is less than 90. In this case, the value of cos theta lies between +1 to 0. In the last diagram, if the given surface is tilt, tilt, tilt and become parallel to the electric field intensity, then its area vector is perpendicular to the direction of electric field intensity. If theta is 90 degree and cos 90 always be 0. In this case, no any electric field line crossing the given surface. The field lines above and below to the surface, no any electric field line will cross the surface. If no electric field line crosses the surface, then the electric flux becomes 0. Cos 90 degree also 0. By using these three diagrams and concept and value of cos, we can understand how can electric flux is proportional to cos theta. The angle is 0 degree, value of cos is maximum. In this diagram, maximum number of field lines crossing the area. The angle is 90 degree, value of cos is 0. No electric field line crossing the area. And between these two cases, a general case is also there in which angle is acute angle. As angle increases, value of cos reduces, number of field lines also reduces and flux reduces. By using the three concept, we can form a simple formula. See here, phi is proportional to E A cos theta. Phi is equal to K, proportionality constant K, then E A cos theta. In SI system, the value of proportionality constant always be unity, always be 1. By doing experiment, by finding value of A, E, theta and phi, when we find the value of K in SI system, we receive always 1. Value of K is always 1. So, the final result, the final expression of electric field, electric flux will be phi is equal to E A cos theta. This is the formula by which we can solve the numerical problems based on electric flux. Thank you, students.